It's the last video.
Century, the German scientist Alfred Wegener noticed that the eastern coast of South America and the western coast of Africa fit together nicely, almost like two pieces of a puzzle fitting together. Then Madagascar fit nicely around the side of Africa, while parts of India seemed to have a place as well. Despite heavy criticism, Wegener went on to publish the book The Origin of the Continents and Oceans in 1915, pushing the concept of what he called Urkontinent, meaning supercontinent in German, except in a 1920 edition of the book where, for a single time, he called the land the Pangaea of the Carboniferous, coining the term from the Greek pan, meaning the entire or all, and Gaia, meaning earth. Of course, it was the Latinization of this word that became the more common phrase now, Pangea. And today, Pangea and the larger theory of plate tectonics are more or less common knowledge. Beyond that, though, I don't know if I've ever actually seen a good prediction on what the continent actually looked like. Most maps you'll find are either too simplistic
Chat, y'all tapped in with
or
Pangea?
just an artistic representation of Pangea, which can trade accuracy for aesthetic. So what I'd like to do today is
Oh, y'all
make
skipped
a
that.
rough estimate of what some of the geography of Pangea was like, and hopefully by the end we'll have a cool map or something. Obviously, this will just be an approximation based on what we know so far about the supercontinent. So with that in mind, let's get started. First, Pangea itself existed for around 160 million years, forming around 335 million years ago, and breaking apart roughly 175 million years ago. Over this time, Earth's
60
geological
million
engine was still
years.
turning underneath, meaning that on a geologic timescale, Pangea would have been constantly changing, and so one general map of Pangea can't really be made. Instead, we're going to need to pick a specific time in Pangea's past to look at. This one's going to be a bit arbitrary, but we're going to aim for between 190 million years to 230 million years ago. This was around the time of the Triassic-Jurassic extinction event, during which 20 to 30% of all marine species went extinct. For this time, the most accurate map for Pangea I could find was this one. But using this, we can now begin to look at specific features, and to start, I'd like to look at some of the mountain ranges that would and would not have existed during this time. For starters, nearly every major mountain range on Earth today had not formed yet. The Himalayas, for example, only began to form 50 million years ago when India collided with Asia. And overall, it was the tearing apart of Pangea that actually gave us many of our mountains. And the reason these all happen to be our tallest is because they haven't had enough time to erode. So to find out what would have been around during this time, we need to look at some of the oldest mountains remaining on the Earth, such as the Appalachian Mountains of the United States, the Little Atlas Mountains of Morocco, and the Scottish Highlands of Great Britain, all of which are nearly 500 million years old. Now, it just so happens that these three mountain ranges would have formed a single continuous mountain range across the supercontinent called the Central Pangean Range.
Okay.
And while none of these ranges stand
Making sense now,
particularly
chat.
high today,
It's kinda
four
making sense,
different
I ain't gonna
mountain-building
lie.
events in the past produced a mountain range that was once as tall as the Himalayas are now, essentially separating the continent between the two remnants of older supercontinents, Gondwana and Laurasia. It was only with several hundred million years of weathering and erosion that these once great mountains were whittled away to the gentle slopes of today. However, there were of course other mountain ranges here as well. Nearby, the Laurentian Mountains of Quebec reaching into Greenland, for example, were also created during the Grenville orogeny, making this area of Pangea, occupied now by Canada and the United States, some of the most mountainous land on the Earth at the time. Then there was the Guiana Shield, a series of mountains and highlands in South America with a history that extends back nearly 1.7 billion years, though you can just barely make it out on modern elevation maps of the region. We also would have seen some of the earliest mountain building in the Andes with the start of the Andean orogeny. These would have been just the beginnings of mountains, however, and nothing like what they are now. Then, as the lower section of Pangea, what was previously Gondwana, began to tear itself apart, splitting Africa from South America, mountains were created around the divide, resulting in the mountains of eastern Brazil and western Africa. South Africa is actually where many of the world's oldest mountain ranges are today, with the oldest being the Makonjwa Mountains. Lastly, I want to talk about the Verskynarajane, which was another substantial mountain building event that led to the growth of the Alps and the Pyrenees in Europe and spread all the way out to the Ural Mountains of Russia and the Tian Shan Mountains of Central Asia, as well as many other mountain ranges sprawling all the way to the far coastal Primorye region, also in modern-day Russia. This places mountains roughly along these lines on our map of Pangaea, and with that, we finished making the important mountain ranges at the time. After mountains, next I'd actually like to talk about the ocean. First, there was the Panthalassa Ocean, the ocean which encompassed most of the world, with its name literally translating into the All-Sea in Greek. And then we'd get the beginnings of the Tethys Ocean, if considered separate from the Panthalassa Ocean, and this body of water would have been around 60 million square kilometers, a bit smaller than the Indian Ocean today, but still much larger than the Arctic Ocean. What I'm interested in, however, isn't the size of these oceans, but how the ocean during this time would have influenced the climate and ecology of the land. I don't think anyone will be surprised to hear that the ocean can affect climate in multiple different ways. In terms of rainfall, lands directly beside the ocean will typically experience greater amounts of it, while the continental interiors, the lands furthest from the ocean, will become increasingly arid.
I never heard of the Indian Ocean, chat.
Across Central
Y'all gotta
Asia
put me
today,
on.
where due to its remoteness, a band of dry regions can be found crossing nearly the entire body of Asia. But I wish it were that simple. The thing we really need to look at is ocean currents, or how the waters of the ocean would have circulated around the world during this time. Now, there isn't really great fossil evidence for what ocean currents would have been like, so there's nothing really tangible for us to go on. But we still know how the Earth was rotating, basically the same way it does now. And because of this, we know that the wind patterns across the Earth would be virtually the same as they are now, meaning they'd look like this. Now, it's the winds that push surface waters around, so knowing these winds, we can reconstruct a general schematic for water circulation, at least at the surface. First, by the equator, both winds from north and south push the water in a westerly direction, creating an ocean current moving to the west across equatorial waters. Because it's at the equator, these waters will also be warm water currents, which will be important later. This equatorial current would continue flowing westward from the Panthalassa Ocean, pushing warm water into the Tethys until it reached land. Where this happened, the waters would have been diverted around. In the northern hemisphere, this sends water upwards and eventually back out, cooling down in the process. In the south, well, a similar thing happens as the water deflects and cools down a little before getting sent back east. Tracing these water movements onto the other side of the continent, we'd still have that westward moving current at the equator due to the trade winds. In the north, this current would have mostly deflected downward, with some of it straying into this northern inland ocean area. The downward flowing waters would begin warming back up, eventually joining the equatorial current, completing the northern ocean gyre. In the south, the current would have to travel a bit further until it came into contact with this shoulder of land. Here, the waters would divert around as well, with some of them traveling back up north, again warming in the process. And then some of the water would also divert to the south and travel as cold water across the southern end of Pangaea until joining with the currents here and keeping on eastward, completing the southern ocean gyre. And there you have it, a basic illustration of what the ocean currents that interacted with the lands could have looked like. Lastly, and I'm not going to really explain why, there would have been a yearly equatorial monsoon.
We got past the oceans and the mountains.
From the Panthalassa into the Tethys,
going on?
inundating many of the lands
that hurricane, one nigga?
ocean with great amounts of water. Knowing these simple characteristics about the Earth and its ocean at this time, we're almost ready to start figuring out the land cover. But before we do that, we need to know how different the conditions of the Earth would have been compared to what they are now. Firstly, 200 million years ago, average carbon dioxide levels would have been around 1,850 parts per million in the atmosphere, compared to 400 parts per million we're hovering at today, meaning the CO2 concentrations around this time would have been about 5 times greater than what it is today, and 6 times greater than what it was before the Industrial Revolution. This would have resulted in global temperatures averaging roughly 3 degrees Celsius warmer than modern times. And while this might not sound like a lot, fossils from the North Pole 200 million years ago show subtropical and even some tropical plants growing here. and there's absolutely no evidence of glaciers or really any ice existing on Earth at this time, besides maybe within the mountain ranges. In other words, this would have been a greenhouse Earth, where even the North Pole could have been covered in tropical rainforests if the moisture levels were right. Because only warm climate environments could have existed at this time, this rules out the existence of any large temperate environments. So if temperature was less of a deciding factor at the time, this would have made moisture the primary determining factor for the environment. Because of this, the lands of Pangaea would have been balanced between basically two radically different environments. Where it was wet, there would have been forests, and where it was dry, there would have been hot deserts. And of course, where it rained a moderate amount, a narrow tropical savanna would have appeared as a transition zone between the two extremes. Using the ocean currents and mountains, then, we can start to figure out where there might have been forests and desert, and then fill in the lands between them with savanna. To start, I'm first going to look at the ocean currents. Cold water evaporates very little, producing very low levels of moisture in the atmosphere, which in turn produces only small amounts of rain. So, beside lands with cold currents running along them, I'm going to put deserts. Inversely, where the surface waters are warm, evaporation occurs more readily, filling the air with moisture which eventually falls back to the surrounding earth as rain. So wherever warm waters flow beside the land, I'm going to make into forest. These trends still clearly exist to this day, by the way, like off the coast of California, where cold ocean water moves, turning the land here pretty arid and creating environments like the Mojave Desert, while on the other side of the US, warm Atlantic waters flow up from the Caribbean, resulting in a much more humid eastern United States. This is also true for South America, Africa, and Australia. However, I mentioned earlier that the further into the interior you go, the likely the drier it would become, so I'm also going to push the deserts further into the interiors where they already exist. On the opposite end of this, as I mentioned before as well, a seasonal monsoon would have come into these lands, sending moisture further inland, likely pushing the forests at the equator deeper into the continent. The forest would likely extend all the way to the central Pangaean mountains, but no further, making one side of the mountain range extremely wet and rainy, while the other side dry and desert. Again, we see this today in places like India, where moisture is brought all the way up until the Himalayas, and the lands on the other side, like Tibet, are extremely arid. This is called the rain shadow effect. So the equatorial forest would likely not have
Man,
caused
I want
all
to
the
see how
central
this shit,
Pangaean mountains.
you know,
This also would have prevented forests from moving too far
how
into
the shape
western
shapes.
Pangaea. Last
Well,
of
for
it,
now.
we're going to place narrow savanna regions around the edges of the land, as the ocean usually acts as a moderating force for temperature and humidity.
I mean, he kind of explained it in the
So,
beginning,
get
but
a
I
map
kind of
that
want to
looks
like,
this.
you know, like
And
a
using
real.
this, I can use
He
satellite
talking about
maps to add a
the
little
oceans and
texture,
shit,
and that's about as good of a
mountains.
map as I can create without any more information. And the only better method I can come up with is to collect all the plant fossils dating back to around this time, determine what type of environment these plants would have grown in, and use them to reconstruct the landscape of Pangaea. But something like that is a job for more than just one person, and would actually require pretty substantial collaboration. So that's where I'm going to need to stop. I hope you enjoyed this video, and if you'd like to keep seeing more like this, I suggest checking out my Patreon. I don't do sponsorship.
No.
These plants would have grown in, and used them to reconstruct the landscape of Pangaea. But something like that is a job for more than just one person, and would actually require pretty substantial collaboration. So that's where I'm going to need to stop.
I'm looking at this shit. I don't know why I think it's still gonna keep playing. Alright, bet. That's the end of the video. That's gonna be the end of the stream too. If you on the stream right now, tap into the pin comment, bro. That's where everything that you missed from the stream, you go catch it on the clip channel. If you own a clip channel, click the comments, man. Comments. I'm fried. Comments. Yeah, one of those type shit. Hey, bet. I'm gonna catch y'all boys. What's this? I'm gonna catch y'all boys on Tuesday.